We're going to look at some trig stuff. So we're going to find some side lengths and maybe find some angles and then do some applications. So sometimes the hardest part is setting up the triangle and what you have. So I have an angle here. This side is the opposite. This side is the hypotenuse. So the trig function that goes with opposite and hypotenuse is sine. So sine of theta is opposite over hypotenuse. And then we'll do some algebra to solve. So we can multiply both sides by x. And then get x by itself by multiplying both sides by sine of 32. Now, when we plug this in our calculator, we're going to make sure our calculator is in degree mode because our angle is given in degrees. So x is going to be 20.8. Let's get another one. Here's our angle. I have opposite and adjacent. So the trig function that goes with that is tangent. So tangent 75 is opposite over adjacent. And then we'll do some algebra. I can multiply both sides by 21. So x equals 21 tangent 75. So x equals 78.4. All right. Angles here. So I have adjacent and hypotenuse. So that is cosine. So cosine theta is adjacent over hypotenuse. I can multiply both sides by 30. So x is 30 cosine 23, which gives 27.6. All right. Opposite. Adjacent. So tangent 41 is opposite over adjacent. When we have x in the denominator, we can actually just flip-flop the x and the left side. So we get x equals 15 tangent 41, which equals 17.3. All right, let's see. We have adjacent and hypotenuse. So cosine 64 is adjacent over hypotenuse. Same thing here. I have x in the denominator, so I can switch them. So x equals 3 over cosine 64, which gives me 6.8. Last one here, we have opposite and hypotenuse. So sine of 18 is opposite over hypotenuse. So x is 25 over sine of 18, which is 80.9. All right. If we're going to find the angle measure, we are going to have to isolate the trig function, and then to solve for theta, we're going to have to use the inverse trig. So if we have sine of theta equals x, we can take the inverse sine of both sides. So theta is sine -1 of x. Same follows for the others. So inverse cosine of x and inverse tangent of x. All right. So I have an angle. I have adjacent and hypotenuse. So cosine of theta is 18 over 23. Then I'll do the inverse of both sides. So inverse cosine 18 over 23. And that will give me 38.5 degrees. I have opposite and hypotenuse. So sine of theta is 5 over 21. So theta is inverse sine of 5 over 21, which is 13.8 degrees. All right, we have opposite and adjacent, so that's tangent, opposite over adjacent, and then theta equals inverse tangent of 17 over 18, which gives 43.4 degrees. We have opposite and adjacent, so another tangent. And then theta is inverse tangent of 39 over 20, which is 50.8 degrees. All right, we have opposite and hypotenuse. So sine of theta is 29 over 52. Theta is inverse sine of 29 over 52, which gives me 33.9 degrees. And the next one here we have hypotenuse and adjacent, so cosine theta, 12 over 19, so theta is inverse cosine of 12 over 19, which gives 50.8 degrees. Okay, we can solve right triangles. All that means is we're going to find all of the missing pieces. So I'm going to call this X, call this Y, and we can call this B because it's angle B. Okay. Honestly, it doesn't matter where you start because it is in that order. That's where I'm going to start. So to find BC, I'm going to use what I already have. So I know this angle. So this is going to be opposite and adjacent. So I'm going to use tangent 72 is opposite over adjacent. So X equals 15 times tangent 72, which equals 46.2. Okay. Next one is AB. So let's see. I know the adjacent, and I'm trying to find the hypotenuse, so I can do cosine of 72 is adjacent over hypotenuse. So the hypotenuse is 15 over cosine 72, which gives me 48.5. And now angle B. All the angles in a triangle add up to be 180. So I can subtract the 72 and subtract the 90 to get the missing angle, which is 18 degrees. Okay. Do it all again. So RT would be opposite and hypotenuse. So sine of 34 is opposite over hypotenuse. So that's 42 sine of 34, which gives 23.5. Let's see, to find ST, I can do cosine. So cosine 34 is adjacent over hypotenuse. So 42 cosine 34, which will give 34.8. And then the angle we can do again by doing 180 minus 90 minus 34 to give 56 degrees. Okay. let's see, JL. Two ways we can do this one. We can use trig. Or we do Pythagorean theorem. So that's probably what I would do. 7.6 squared plus something squared equals 8 squared. So let's see, 64 minus, let's see what 7.6 squared is, because I'm not sure. 7.6 times 7.6, that's 57.76. So 64 minus 57.76 is 6.24. And the square root of that, 6.24, is 2.497. So we can round that to just 2.5. Now we can use some trig functions to find the angle. And this one doesn't really matter where you start. Let's find this angle. And so the two pieces I know here are adjacent and hypotenuse. So I would use cosine of theta is adjacent over hypotenuse. So theta is going to be inverse cosine of 7.6 over 8. Which gives 18.2 degrees. And then what I would do is I would take 180 minus 90 minus the 18.2, and that's going to give 71.8. Okay. And then we can do same stuff here. So I would do 21 squared plus 22.5 squared equals something squared. So let's see. 21 times 21 is 441 plus 22.5 times 22.5 gives me a total of 947.25. And then I gotta square root that. So square root of 947.25 is 30.8 rounded. All right. Now I'll use trig to find the angles. So let's do this theta. So I have opposite and adjacent. So tangent theta is 22.5 over 21, which gives 47 degrees. And then you can use trig to find the other one, or I would do 180 minus 47 minus 90 to get 43. All right, let's look at some applications. So applications pretty much just means word problems. Okay. So a fire started at a campsite located 8 miles from the base of a mountain. A fire started at a campsite. Okay, I think that's supposed to be is located 8 miles from the base of a mountain. If the angle of elevation from the fire to the top of the mountain is 14 degrees, how high is the mountain? Sometimes a picture might help, and sometimes it doesn't. I feel like everybody likes to roast my artistic abilities, but sometimes a picture helps. So maybe this can be your entertainment for the day. I will draw pictures. So this is my fire, and there's my mountain. So we are located 8 miles from the base of the mountain. The angle of elevation from the fire to the top of the mountain is 14 degrees. How high is the mountain? So we want that value. So I have an angle, and I have opposite and adjacent, and this is definitely supposed to be a right angle here, so that I can use this trig stuff. So that goes with tangent. So tangent 14 is opposite over adjacent. So the mountain is 8 times tangent 14, which gives me 2. So the mountain is 2 miles tall. A man, so here's my man, standing 85 meters from the base of a tower. So there's my tower, 85 meters. If the tower is 200 meters tall, what's the angle of elevation from the ground where he's standing to the top of the tower? So I have opposite and adjacent, so it's another tangent. The tangent theta is 200 over 85. So find the inverse. And that gives 67 degrees. All right. 32-foot tall ladder rests against a vertical wall. So there's my wall. There's my ladder. 32-foot ladder. If the top of the ladder reaches a point 18 feet up the wall, what angle does it make with the ground? So this is opposite and hypotenuse. So that is sine. So sine of theta is 18 over 32. So I can do the inverse and get 34.2 degrees. All right. Lana's kite is flying 60 feet above the ground. So, okay. Here is my kite. My guess, we're going to do something like this. So 60 feet above the ground, the angle of elevation from where her hand is holding the string is 48 degrees 8 minutes. If her hand is 5 feet from the ground, find the length of the string. All right, let me back it up here before I do this. So I've got a person holding the kite. From where her hand is holding the string. Okay. See, I don't, oh, okay, her hand is, I was like, I don't like that. Okay. Okay. So my kite is 60 feet above the ground. Well, her hands from here to here is 5 feet. So really, and this is not drawn to scale, but this right here is really 55. So that's 60 minus 5. The angle of elevation is 48.18. So that's 48 plus 18 over 60, which is 48. I think 0.3. If I divide both by 6, that's 3/10. Yep, so 0.3. So 48.3 degrees. Find, what are we finding? If her hand is 5 feet above the ground, find the length of the string. So that's going to be this right here. So let's see, we have opposite and hypotenuse. So sine of 48.3 is 55 over x, where x is actually 55 over sine of 48.3 to give 73.9 7 feet. Right. A ramp is being built to access a door that is 1.5 feet above the ground. Find the length of the ramp if the angle of elevation must be 8. So there's my ramp, 1.5 feet above the ground, 8 degrees, and we want the length of the ramp. So opposite and hypotenuse, so sine of 8 is 1.5 over x. X is 1.5 over sine of 8, which gives 10.8 feet. Ooh, okay. Sarah is standing 35 feet from the base of a rock wall watching her 2 sons. So here she is. 35 feet. We got Max and John. They're climbing the wall. Oh, wow. The angle of elevation is 38 to Max. So let's say Max is right here. So the big angle is 38. And then 27 to John. So the small one is 27. How many feet above John is Max? All right. I'm going to use some different colors here. I'm going to do the big triangle first. All right, so I have 35, and I need to find that whole length. So that's opposite and adjacent. So tangent of 38 is x over 35. So x is 35, tangent 38. And that gives me 27.3. I'm going to do blue for the smaller triangle, because I need to subtract the difference here. So tangent 27 is, use a different letter, y over 35. So y is 17.8. And then I will just subtract those two. So 27.3 minus 17.8 gives 9.5 feet higher. All right. Building A is 464 feet tall. Building B is 321 feet tall. Dale is standing between the two buildings. So we'll make this one A, so 464. Make this one B, 321. The angle of elevation from the point on the ground where Dale is standing is 75 degrees to the top of A and 48 to the top of B. How far apart are the buildings? All right, so it looks like I need to find this distance and add them together. So let's see, opposite and adjacent, so tangent. Tangent 75 is 464 over x. So x is 464 over tangent 75, which gives 124.3. And then same thing over here. Tangent 48 is 321 over y, and y is 289. So then I just add the two together. 124.3 plus 289 gives 413.3. All right, now let's look at some angle of depression now. All right, so from the top of a lighthouse, 150 feet above the sea level, the angle of depression to a boat is 28 degrees. What's the horizontal distance? So that's opposite and adjacent. So tangent 28 is 150 over x. So x is 150 over tangent 28 to give 282.1. Angle of depression from a helicopter to a landing pad is 34 degrees, 54 minutes, 8 seconds. The horizontal distance from the helicopter to the landing pad is this. Find the altitude. So I gotta turn that 34 to 54 over 60 and 8 over 3600. So it's gonna give me 34.9. And we have opposite and adjacent again. So that's tangent. So tangent 34.9 is opposite over adjacent. And that's going to give me 837.1. All right, Henry is sitting in a tree 32 feet above the ground, watching a deer. If the deer is 57 feet from the base of the tree, find the angle of depression. We have another tangent. Tangent theta is opposite over adjacent. So then we can do the inverse to get 29.3. Right, a wire is attached from the top of a post to a point on the ground. 24 feet away from the base of the post. The angle of depression from the top of the post to the point where the wire is attached is 61. Find the length of the wire. So that's this one right here. So this is going to be cosine because we have adjacent and hypotenuse. So cosine 61 is 21 over x. So x is 21 over cosine 61. And I definitely meant 24. Right here, 24. So that gives me 49.5. A scuba diver spots a shipwreck at an angle of depression of 26 degrees. The angle of elevation from the scuba diver up to his boat is 53. If the shipwreck is located directly below his boat, find the horizontal distance between the scuba diver and... Wait, if the shipwreck is located directly below his boat and the horizontal distance between the scuba diver and the shipwreck is 120 feet, find the vertical distance between the shipwreck and the boat. So, all right. Here's my scuba diver man. And then here's his boat. And here's the wreck. So the angle of depression was 26. The angle of elevation was 53. The horizontal distance was 120 feet. We want to find the vertical distance. So I need to find this and add them together. So opposite and adjacent. So it's going to be tangent 53 is x over 120. So x equals 159.2. And I got to do this one. So I have opposite and adjacent again. So tangent 26 is opposite over adjacent. So this gives me 58.5. And then I add the two together. So I get 217.7. And that is all.